just reading through this real quick. Rotational symmetry. When the figure at the right is rotated about point P, which is right in the center of the shape, by 120 degrees, 240 degrees, the image looks just like the pre-image did. Remember, pre-image is the original, image is the new. The figure has rotational symmetry. So anytime you can turn something about a point that's in the middle and it looks exactly the same, that figure is said to have rotational symmetry. Not line symmetry. We covered line symmetry a couple days ago. Rotational symmetry is when you rotate it around a certain point and it looks exactly the same. The figure has rotational symmetry of order of 3. And it has rotational symmetry order of 3 because in one whole circle, there's 3 times when that shape's going to look exactly like it did originally. So that's your order when you're talking about rotational symmetry. You have 2 things that you're dealing with. One is order, and the other is magnitude. The order is how many times it looks exactly the same in one full circle, or looks same in a 360-degree turn. And then magnitude, you find the magnitude just by taking 360 divided by that number that you came up with from the order. And what that magnitude tells you is how many degrees you're turning it before the shape looks exactly the same. So I'm going to start off with number 3. If we look at number 3, we have a rectangle with an X through the middle with diagonals drawn into it. If we rotate this, if you rotate that, and maybe take your paper and do the rotation, you're going to figure out that the order is 2, because twice it's going to look exactly the same, and the magnitude is 360 divided by 2, which is 180 degrees. So every time we turn that shape 180 degrees, it looks exactly the same. And again, we're rotating it about that point right there in the middle. If you look back up now, let's go back up to number 1. We have a square. If I could draw a square, put a point right in the middle. Our order this time, how many times is it going to look exactly the same? It's going to be 4. The magnitude, 360 divided by 4, which is 90 degrees. So every time we turn it 90 degrees or a quarter of a whole turn, it's going to look exactly the same. Number 2, 40gon, and they're telling us that it's regular, but you got to remember that a 40gon means a shape that has 40 sides, and if it's regular, that means all the sides and angles are the same. I'm not going to try to draw this because if I did, it'd end up looking like a circle. But if it is that, just think back to the square. The order for the square was 4, which was the same as the number of sides. Well, the order here is going to be 40. And to find the magnitude, we take 360 divided by 40, and you get 9 degrees. So a 9-degree turn is going to be just a real little small turn. That amount of turn on that picture on a 40gon, it's going to look exactly the same. Number 4, we have a pentagon, and that pentagon has a star in it. Remember, we've got some point right here in the middle that we're rotating it around. Probably see that the order is going to be 5. And to find the magnitude, just take 360 divided by 5, which ends up being 72 degrees. So every time you turn it 72 degrees, it looks exactly the same as it did at the start. And there's 5 times that it's gonna look exactly the same as it did right there in that picture as we go around a full turn or full circle. Number 5, I'm not gonna try to draw number 5, but if you count it up there, be careful with this. The order is 16. We had a picture like this the other day, and we did the line, how many lines of symmetry it had, and you didn't count. If the picture looks like this, remember, if you counted that line up there, you didn't count it down here for line symmetry. But for order symmetry, you count both of them. And then the magnitude, 360 divided by 16 comes up to be 22.5 degrees. So every 22.5 degree turn you make of your paper, that shape looks exactly the same. Then number 6, be careful on a problem like number 6, because that's a hexagon, but they stuck this extra thing in there. So when we go to spin it, it's not gonna, if we spin it so that this side's on top, it's not gonna look the same as it did originally. So our order here is 3, and our magnitude, 360 divided by 3, which is 120 degrees. All right, what we're going to cover today, rotations. Key things about rotations. Number 1, hopefully some of you have done rotations in the past. 3 key things when you're doing rotations. You got to know the angle that you're rotating it, you got to know the direction, and you have to know the center. We're going to talk more about that here in a little while. Our center will normally be 0, 0, which is the origin if we're on a coordinate system. We're also going to rotate images, and this will probably be new to most of you, that uses any angle of rotation, and maybe some that aren't on the coordinate system, so you just have to do it out without actually having the coordinate system to look at, or actually having a rule. And then the third thing, identify rotational symmetry and order and magnitude. Find their order and magnitude. That's what we just got done talking about off the first worksheet. So those are the things that we're going to cover today. All right, we're going to watch this video. I'm going to get the video from here instead because the thing's messing up. So we're going to watch this video.
We're going to do our third type of transformation, and that is rotations.
As this video is going on, you want to write down some of the stuff that he says, some of the key ideas.
Like reflections.
On this first slide, under a rotation, a figure is rotated or turned about a given point. That's important. Write down some of that.
A rotation is a turn. Under a rotation, a figure is rotated or turned about a given point. That's very important.
So write that down in your notes.
About a given point.
Some of this will
Kind of
be
like
sort
a
of important.
CD spin in a CD player. That CD is being rotated about that center thing that pops up, that little cone, spins about the given point. The majority of our rotations, we will concentrate on, the center of rotation will be the coordinate 0, 0. A complete turn is 360 degrees. Why would that be, a complete turn? Yeah, there's 360 degrees in the circle, right? A half turn, 180, and a quarter turn is 90. A rotation has 3 crucial pieces of information that we need to know before we can perform one. One, we need to know the center of rotation. Usually it'll be 0, 0 for our purposes. We need to know the amount of the turn expressed as a fractional part of a whole, right? So if it's a 180, what else could I call it? A rotation of a half. If it's 90, we could call it a quarter turn. Or as the angle of degrees, angle of rotation in degrees. This is what we will normally use, angle of rotation in degrees. Then the third thing we need to know is the direction of rotation, clockwise or counterclockwise, which is sometimes the topic of great frustration among students. And I'll see them sit there and look up and start moving their fingers, which will work. However, I want to point out something that you can use in your environment. Everybody look over there at that square thing with the circle in the middle and the hands on the wall. That's what clocks used to look like before they were digital, all right? I know you laugh, but some people, young children especially, they get to a certain point, they can't read a regular clock because they grew up with digital clocks. That is a clock. That's an old-fashioned one, I know, but see the little red hand there? This is where you shake your heads up and down. Yes, you see it? Okay. See the way the red hand is going? That's clockwise. Which means the other way is counterclockwise. So if you forget, use your contextual clues, your environment. I won't say don't look at the clock. Go ahead and look at the clock. It's not a problem. That way is clockwise. This way is counterclockwise. If you have a watch that has the hands like mine I'm wearing today, feel free to look at that. All right, these are our rules. Now, these rules are specifically for those about 0, 0, and they only work when the center of rotation is 0, 0. However, like I've said before, the majority of cases we will have this year, the center of rotation is going to be 0, 0. First one, 90 degrees clockwise spin. A 90 degrees clockwise spin. What happens is you have your original coordinates. The new coordinates, you will change places, just like we did in the rotation with y equals x, or the reflection, I'm sorry. But after you change them, the original x, which is now your new y, you change its sign. Because what's happening is if it's 90 degrees clockwise, if it's in the first quadrant, it's going to the second quadrant, which means your y coordinate is going from positive to negative. Your new y is going to be negative. The next rule, 90 degrees counterclockwise. So this is going that way from like quadrant 1 to quadrant 4. You'll change their places, so the y will become the x will become the y, and your new x, the old y, becomes negative, or you change its sign. Now realize you change the sign. That doesn't mean it's always negative, because if you start with a negative one, it's going to make it positive. The next one is 180 degrees clockwise or counterclockwise. Why would it be both? Yeah, halfway is halfway. Either way you go, you're going to end up halfway, right? Exactly. Doesn't matter which way you go, 180 degrees, you're forming a semicircle, so that's halfway around. And what you do is the coordinates stay in the same place, you just change their signs. And we have one more, and this is my favorite rotation personally, and usually it's students' favorite rotation. What is it? What's that? 360. Why is it everybody's favorite rotation? You don't have to do anything, that's right. Nothing changes, why? Because you finish where you started. It's one complete revolution. Yes, you will have at least one of these on your homework. That's everybody's favorite problem all year. Those are the 4 rules. You want to make sure you commit those to memory. Sorry. You're not a day late, you're 2. You're not a day late, you're 2 days. All right, we have a triangle, and it's a rotation 180 degrees clockwise, about 0, 0. Now, before I even start graphing the original, since it's 180 degrees clockwise, I have a rule. The rule tells me to do what? Change the signs of the original. So Q prime, I'm going to map out where the rotation is going to be. Q prime is going to be at -2, -4. R prime is going to be at -1, -1. And S prime is going to be at -4, -1. So what's going to happen here is we're going to start here at 180 degrees. Now this, it's like taking a piece of string and having a pencil on the end of it. And it's going to start here and swing all the way around like that. Ever done that to make a circle? Take something, set it in the middle, take a pencil and piece of string, hold the center, and then make a circle that way? That's what what's that? The spinny thing, called a compass. Ever made a compass, used a compass to make a circle, Marcus? All right, this is the same thing. When we do rotation, it's like that. Bless you. That's what's going to happen. All right, my original Q is at 2, 1, 2, 3, 4. R is at 1, 1. And S is at 4, 1. Q prime is at -2, negative. R is at -1, -1. S is at -4, -1. Does that look right? Should be upside down. That's in the right place. It's rotating 180 degrees. And one way to check it is to make sure R and R prime are equidistant from the origin. Yep, they're both 1 block away from the origin. Now we're going to have a 90 degrees clockwise. So I don't know if you've noticed, what was the first thing I did in that first one? I found my rotation and my center of rotation, right? I found what I was going to do. Because I'm not even doing any graphing until I know what all my coordinates are. That's what we do when we rotate. Unlike the translation where we went ahead and we had to plot it and then count. Same thing with the reflection, we plotted it and then counted. Here, I'm going to make sure I have all my coordinates in place. What's the rule for 90 degrees clockwise? I take the coordinates and change their places, and then which one becomes negative? The old x, which is the new y. Isn't that it? 90 degrees clockwise. Yes. The original x, which is now your new y, I changed the sign. Right, so A prime, switch their places. And then the old x, which is your new y, I changed the sign. B prime would be 1, -5, and C prime is at 1, -1. Right, the original, there's A, B, all right, what kind of triangle is it going to form? Don't everybody shout right triangle at once, okay? It's a right triangle, right? Yes, it is. It's always a critic. Crap. Are you back? You okay now? You talk about me being obsessive, compulsive. All right, A prime. Now, what should this look like when it's done? 90 degrees. What will happen to it? Now, not half, 1/4, right? So it's just going to point down. All right, I like to visualize that before. When I forget my original, I think, well, if I did it right, what should it look like? That way I know once I get it graph whether or not I did it correctly. A prime is at 1, 2, 3, -1. B prime is at 1, -5. And C prime is at 1, -1. Okay, that's what happened. Turned it down 1/4. So it's pointing down. We could also use the rules given something like this to figure out that it's original, correct? How would we do that? If we're given the coordinates after the rotation, how could we figure out the original coordinates? Yeah, reverse the rule, right? Exactly. A large mechanical shovel is used to move gravel. If the coordinates of the shovel are A, 0, 0, B, -2, 2, C, -4, 4, and D, -4, 2, after being raised by a 90 degrees clockwise rotation, about 0, 0, what were the coordinates in its original position? So we could reverse the rule, right? Or we could do what? This is a 90 degrees clockwise, so 90 degrees clockwise. We take X and Y, and they become this. So what would we have to do? Take this Y, take this one, move it over here, and then put another negative sign in front of it, correct? Right? And then take this one and move it back, the Y. Well, that's the original A. That would be easy, because 0, 0 is still going to be, yeah. If your center of rotation is 0, 0, and one of the coordinates is right at 0, 0, that means what? It's not moving any of the way, right? Because that's right at the center of rotation. The original B, these two would change places. And this is going to be -2, so it's -2, -2. The original C is going to switch places. -4, -4, and D would be -2, -4. What's the rule for 90 degrees counterclockwise? What do you do when you have a 90-degree counterclockwise? What's the rule for that one? Take X and Y and you do what? Flip them and change that one, right? Huh. Well, after 90 degrees clockwise rotation, how would I move something back? By doing a 90-degree. Could I have done that instead? Could I have said, hey, since I'm going backwards, I'm actually doing a 90-degree counter. Would it have given me these results here? Would it? Let's figure it out. assuming this is the X and Y, we change their places, and then this would become negative. This one right here. Yep, it would work, wouldn't it? Change their places, make that one work all the way through. So there was really two ways to do this. Why? Well, when you look at the rules, 90 degrees clockwise and 90-degree counterclockwise, what are the rules? They're opposite of one another, right? Because those are opposite rotations. So that's what they're really are. The other thing you'll have to do, very limited, I don't like to do a lot of this, is identify the center of rotation, the angle of rotation, and the direction of rotation. Mainly I do these just so I want you to picture or figure out which one's the original and which one's the rotation. Mostly I'm not real super concerned with the center of rotation. Just basically the direction and the angle. 100 degrees. Now this one. Where am I starting? The one that faces up or the one that faces sideways? Sideways. How do you know that, Chris? You were correct. It doesn't have the prime marks. Very good. So to go from here to there. What part of a circle is that? Now let's complete the circle. Or we could even take and put a circle in there. Started there and end up right there. That's not very good. You have to see it, but it kind of looks that way, doesn't it? That's because I was off when I did it. But really, when you start here and just end up right here, well, the way I like to think about it is you're starting there, right? With this line, and you're ending up right there. So what does that make? I draw that. 9. That's 1/4 of the circle, right? So it's a 90 degree, and which way is it? Use the clock, that's what it's there for. This is a 90 degree counter. Very good. How many answers are there to this problem? There are 2. Could it be the other way? Sure. You could have said, well, I'm going to start here. See if I can get a color that I can use. I'm going to start right here and go this way. So you're going to end up with that. So Brad, what's the other acceptable answer? 270 clockwise. There is something on the test like this, and the reason why I like this question is 2 right answers. So counterclockwise and clockwise, you pick one. What's the important part? Making sure you get the correct degrees. Yeah, the correct number of degrees. That's the other thing you'll have to do in your homework. And all I'm concerned about is the direction and the number of degrees. If it's 180, is there a wrong answer? If it's 360, is there a wrong answer? No, because both of them, doesn't matter which way you go, you end up in that place. So the 90 and the 270 are the only ones. So of course, let's think critically. If I were a math teacher on the test, what would I put on there? The example that there's no way I could get a wrong answer, or would I do the other one? One would think. Pages 308, 309, 1 to 18 all.
All right, on the video, you should have written down some notes, dealt with rotations, the rules. I'm gonna, again, on my PowerPoint here, I'll have the rules up here also. Go ahead and copy this down. Rotational symmetry, that's the worksheet that we talked about at the beginning of class. Remember, rotational symmetry, two things you're looking for. Order of rotational symmetry, that's the number of times that if you take a shape and rotate it around a whole circle, how many times it looks exactly the same. And then the magnitude is 360 degrees divided by the order of rotational symmetry. So divided by the number you got up here and this one. Example, if we look at this snowflake, its order of rotational symmetry is 6, because there's 6 times as you turn it around in a circle that it would look exactly the same. And then to find the magnitude, we take 360 divided by 6. Don't do that. Not that too low. No. So you take 360. Divided by 6, and that gives you 60 degrees. So the magnitude would be 60 degrees. That means every time you turn it 60 degrees, it looks exactly the same. Little TV screen here. You get rid of these bubbles over here that act like they're not there. Order of rotational symmetry. Times it's going to look exactly the same as we rotate it around in a circle. It's going to be 2. The magnitude, 360 divided by 2. That's 180 degrees, so its magnitude is 180 and its order is 2. The cow, if you look at the cow, we rotate it around in a circle. Well, the number of times in that circle it's going to look exactly the same as it started is just 1. So to find the magnitude, 360 divided by 1, which is just 360 degrees. And this colorful band here, the order, it's going to be 2. Twice as you rotate that all the way around, it's going to look exactly the same. And then that means the magnitude, 360 divided by 2, which is 180 degrees. So order, magnitude. Don't get this confused with lines of symmetry. If we were looking at the snowflake and we wanted lines of symmetry, there would only be 3 lines of symmetry. The order is 6 for rotational symmetry, but the lines of symmetry is something different. And don't forget, for everyone, when you're doing rotational symmetry, you're looking for some point right in the middle that you're rotating that shape around. All right, these are the rules for, and you got these rules off the video also. These are the rules for clockwise, rotating clockwise. Remember, anytime you're doing a rotation, you need 3 things. You need your center, your angle of rotation, normally, my pen would ever work. Normally our center is 0, 0. That's what we're using the most. And normally our angles are 90 degrees, 180 degrees, 360 degrees. Those are the ones that we're using the most. And then you need a direction. You always got to have those 3 things to do a rotation. And our directions normally are clockwise, if I could spell, clockwise, or counterclockwise. This is written wrong. this should say for a rotation, and to switch that, of 90 degrees. So these are the 4 rules. You got a 90-degree turn, a 180-degree turn, a 270-degree turn, and a 360-degree turn. Remember, a 90-degree is a quarter of a turn, 180 is a half a turn, a 270, which we don't use a whole lot, is 3/4 of a turn, and the 360 is 1 full turn. The reason we don't use 270 a whole lot, because if I have a shape here, whatever that shape is, and I want to rotate it 270 degrees clockwise, it's going to end up right here. Well, if I took this shape and I rotated it 90 degrees counterclockwise, it would end up in the same location. So we use that a lot more than the other. So you've got those 4 rules for clockwise. Then these are the 4 rules for counterclockwise. And you'll notice this rule, 90 degrees counterclockwise. If I flip back, it says XY goes to negative YX. You switch the X and the Y coordinates, and you take the opposite of the new first one. Well, if I go back and you look right here at 270, it's the exact same thing because of what we said down here. So these are the rules for that, and again, a lot of the rules are the same. If you rotate something 180 degrees clockwise or 180 degrees counterclockwise, I'm on the coordinate system, and something is in this first quadrant and I want to go 180 degrees counterclockwise, I'm going to go there. If I wanted to go 180 degrees clockwise, I end up in the same spot. So for 180 degrees, it's the same whether you're going clockwise or counterclockwise. The guy on the video said that. And then, again, this 270 is the same as the other one for 90. And then 360 is the same for both of them also. 360, the thing doesn't change if you want to rotate something 360 degrees. If it starts here and you rotate it 360 degrees, it's going to end up right back in the same spot. All of these are if you're rotating about the origin. It's the only time that these work, when you're going about the origin. All right, these are a little harder. See if I can do this. Okay, with me watching this. How you doing your homework? When you're rotating something, and this is a little different than probably anything you've done in the past, when you're rotating something 60 degrees, that's not one of our normal angles that we do. This time we're going counterclockwise and we're going about some point other than 0, 0. This is how you're going to do this. See if I can sort of show you here. So, I know these letters are sort of hard to see, but I'm going to use them because I don't want to write in a real dark color. We're going 60, and they talked about this on the video also. We're going 60 degrees counterclockwise, so that means we're moving this direction, and we're going about this point P right here. Well, what you have to do to estimate this is sort of tether point P to each of these points. And we want to go 60 degrees. Well, 60-degree angle, I can sort of estimate how much a 60-degree angle is. Probably a little more than that. Something about like that. So let me redraw it. That's still too small. 60-degree angle, something about like that. So when I rotate this, I want it to come up 60 degrees. So it's gonna come somewhere up in here. Point A is gonna come somewhere up in there. Then what you have to do is you have to see how far you are from A to P. And we wanna go that same distance up to get to A prime. And I'm actually gonna use a yardstick to measure it here just to get a better idea. So A prime's gonna fall somewhere about in there. Do the same thing with B. We're tethering it to point P right there. We wanna go up 60 degrees, which is gonna fall somewhere about in here. So our B is gonna be on that line going out through there. We wanna be about the same distance. So we're gonna end up somewhere about out in here. That's gonna be B prime. C, we do the same thing. Tether it to it. We wanna go out about 60 degrees. Which is gonna come out somewhere about in here. So it's gonna be on that one, on that line. And we wanna be about the same distance. I know you can't see me using the ruler, but all I'm doing is using the ruler. And this is gonna be C prime. I'm actually gonna draw it in a different color so we can see it better. When you're doing these, I'm not gonna ask for some spectacular artsy drawing. And notice my C probably should have been up here a little farther, so it was a little more like that. Notice my triangle's not exactly the same. It should be exactly the same, but my art, not very good. But if we turn it 60 degrees counterclockwise, about this point P, that's where the shape would end up. So sort of what you're doing is you're taking strings and attaching them to each one of those points, and you're turning this shape a 60-degree turn that way. And this is what it's gonna end up looking like, or the position it's gonna end up in. Alright, I'll try this one. I have no idea if I can actually do it or not. We'll see what it comes out like. Let's change our ink color again. Go back to this. Call this A, B, C, D, so I don't get lost. I just put some points on there so I got reference spots to go to. Go from there to there. And we want to go 80 degrees clockwise this time, so this time we're turning around that way. So A is gonna go 80 degrees clockwise. 80 degrees, right angle looks like that, so 80 degrees is almost a right angle. So we want to be up in here, and we want to be that same distance. So we're going to be right in there somewhere. That's going to be A prime.
Teachers, pardon the interruption, but can I have Kenneth Washington and Cody Washington to the main office, please? Thank you.
Got this. We want to go up 80 degrees, so somewhere up in there maybe, about 80 degrees hopefully. Our distance, B is going to fall somewhere about in there. That's going to be B prime. Do the same thing for D. 80 degrees up here. Might be too far. D's gonna fall somewhere about up in here, or D prime will. And then C, 80. Yeah, somewhere about in there maybe. And again, these aren't gonna be exact. Hopefully my picture comes out looking somewhat similar to the original. Should look exactly the same. We wanna connect A, B, and C. That's a terrible drawing. And then we wanna connect C, D, and A. So our shape would end up being somewhere about like that. Let's trace it in a different color. Trace it in red. You're impressed, weren't you, McKenna? You didn't think it was gonna come out, it looked anything like that one, did you? Did you? I will here in a second. Give me a second. Right off the worksheet, what you need to do every time you're doing one of these problems and you're rotating it about the origin is go through and find the ordered pairs of the coordinates of the corners, write them down out to the side, and do the rule first. So we can give these some letters if we want, A, B, C, D, just to make it a little easier to identify. I'll start with A. A is 1, 4. That's A. B, C, D. B is 3, 0. C is -2, -2. And D is -4, 2. Now our rule on the worksheet, it says you want to rotate this 180 degrees about the origin. So the origin, that's our center. So we know we're going around the center. This is our angle. And then our direction, which is clockwise or counterclockwise, they didn't tell us because it's the same for 180 degrees regardless which way you go. The rule, if we go back, we want 180 degrees clockwise or counterclockwise, it doesn't matter. The rule is XY goes to -X, -Y. So we'll go back. So it's XY goes to -X, -Y. So it leaves the ordered pairs in the same order, but does the opposite of both of them. So if I look at this, let's change our color here. Go to black. A prime is going to be -1, -4. B prime is going to be -3, 0. C prime, take the opposite of both those, is going to be 2, 2. And D prime, take the opposite of both those, it's going to be +4, -2. Do this rule first, do all this stuff first, then worry about graphing it, because otherwise you end up being lost. I'm going to change my color again because my shape was already in black. Let's do it in blue. So -1, -4. It'll be somewhere about in there. That's A prime. B prime is -3, 0. Somewhere about in there. C prime is 2, 2. And D prime is 4, -2. So the blue shape here would be our rotation. We rotated it 180 degrees about the origin, and it didn't matter whether we went clockwise or counterclockwise. thing you gotta remember, you got to do the rules first before you try to do any of the graphing. All right, this is number 2 on the worksheet. And if we just go through here, we run through here real quick. I'm going to write the ordered pairs for each of these points. That point looks like 1, -1. This point is 2, 0. You could put some letters on them if it helps you to keep track of them. That point is 5, -3. And then this point is 4, -3. And on number 2, it says it wants you to do 180 degrees about the origin. So 180 degrees about the origin. Again, they didn't tell you a direction because with 180 degrees, it doesn't make any difference which direction you take it. The rule for going 180 degrees, if you look at your notes there, the rule for going 180 degrees either way, XY goes to, if we go back here and just look at the rules. So 180 degrees, again, it doesn't matter if it's clockwise or counterclockwise. XY goes to -X, -Y, so it leaves them in the same order, but makes both of them the opposite. So if we go down through here, this first point right here is going to go to, we leave them in the same order, but do the opposite of both. So it's going to go -1, +1. This one is going to go -2, and then just 0 because you can't do the opposite of 0. This one's going to be -5, +3, and then this point's going to be -4, +3. We graph those. I should have done them in a different color when I did those, but we'll change the color here. Let's go with blue. So we want -1, +1, that's going to be right there. -2, 0 is going to be right there. -5, 3 is going to be here. And -4, 3 is going to be here. So our new shape, not drawn very well, but our new shape going 180 degrees about the origin is going to look something like that. And again, my shape looks too big just because I can't draw very well. All right, next one, number 3, says you want to rotate 90 degrees counterclockwise. So counterclockwise, I'm not going to write the whole thing out, about the origin, and the shape they give us, go back, the shape they give us as coordinates 4, 1, or -4, 1, -5, -4, and this is, they actually do give it letters on here. This is B, this is N, and X is 3, -2. So that's our original shape, looks something like that. So let's see, what was that? B was -4, 1. N was -5, -4. And X was -3, -2. find what B prime, let's change our color here. Color, let's go back to red. We want to find what B prime, N prime, and X prime are. Points here are probably gonna be in the way. Probably gonna rotate it right there about where those points were. I wrote them, should have wrote them somewhere else. Remember the rule for 90 degrees clockwise? Let's go back and look at the rule. Degrees clockwise, that's counterclockwise. 90 degrees clockwise. It's supposed to be this one. Remember, that's supposed to say for 90 degrees clockwise about the origin. So it's XY goes to YX, it switches them and makes the second one the opposite. So on this one, it's going to switch them and do the opposite of the second one. So the second one was going to be a -4, so now it's going to be a +4. This one, it switches them. Makes the second one positive, or the opposite. This one, it switches them. Makes the second one the opposite. So our points are going to be 1, 4. That's going to be B prime. -4, 5, 2, 3, 4, 5. That's going to be N prime. And then X prime is -2, 3. So that's the location of our new shape. If we rotate, remember this is your pre-image, the blue one's your pre-image. And the red one now is your image. If we rotated it 90 degrees counterclockwise. I looked at the wrong one, but I looked at the wrong rule, didn't I? 90 degrees counterclockwise. I think I looked at the wrong rule. Counterclockwise, I did. It's supposed to be that rule. So let's go back and we'll fix it. So it's XY goes to -YX. I just went back too far and looked at the wrong rule. Should have thought about it before I drew it. So counterclockwise, we should have came around the opposite way. So let's do this one in a different color. The red, this is actually 90 degrees clockwise. So I did that one wrong, so let's just go ahead and we'll do one counterclockwise while we do this one counterclockwise, and we'll call it X, or double prime. And let's change our ink color. We'll go to black this time. So we'll go with B, double prime, N, double prime, and X, double prime. And it said you switch them and you take the opposite of the first one, the new first one. So we switch them. This one's going to be -1, -4. N double prime, going back to the original one, is going to be +4, -5. And then X double prime is you switch them around, make the first one the opposite. So 2, -3. Let's graph that and see. Maybe it'll look a little better. -1, -4. It's going to be somewhere right there. That's B double prime. 4, -5. 4, -5. That's going to be N double prime. And then 2, -3. Ooh, that can't be right. 4. No. 2, -3. 2, -3 is gonna come out here. I'm going the wrong way. Not counting right. That's gonna be x double prime. So that's what the shape would look like, rotated. That's this blue one, rotated 90 degrees counterclockwise. And that's what number 3 actually said to do. I did clockwise, I messed up the first time. Number 4, 90 degrees clockwise. We just got done doing one of those, so I'm gonna skip number 4. Number 5 is 90 degrees clockwise also. We'll go ahead and we'll do number 4. So number 4 on the worksheet goes out 2, 2, that's there. That's U. Then 1, 2, 3, 4, 5. 5, that's B. And then K is 5, 3. And Y is 4, 3. Okay, so this is our shape. That's the original shape. I'm just gonna put Y up here. That was 4, 3. K was 5, 3. U, and let's do B. B was 5, 0. And U was 2, -2. So those are the original coordinates. This time we want to go 90 degrees clockwise. Make sure I read the rule right this time. We want 90 degrees clockwise, so it's this rule. XY goes to Y -X. So we want to turn it to Y -X. That means we flip them around and we take the opposite of the second one. So we flip these two around and you got 3 then 4, but the 4 becomes the opposite, so it's a negative. That's Y prime. K prime is going to be 3, -5. B prime is going to be 0, -5. And U prime is going to be -2, -2. So let's see here, let's change our color. I should have changed it before I started that. Let's go to red. 3, -4. That's Y prime. 3, -5. That's K prime. 0, -5. That is B prime. And -2, -2. That's U prime. We connect it. Again, my shape looks awful big, but it's just because I'm drawing my line so crooked. Comes out the same. It's just rotated 90 degrees clockwise around this way. Number 5. Looking at number 5. 90 degrees clockwise, so same thing. So we're changing it to Y So I don't have to go back. Y negative X. That's J. V. And then 2, negative 4 is K. Triangle looks something like that. And J was negative 1, negative 2. V was 4, negative 1. And K was 2, negative 4. Our J prime, V prime, and K prime. Switch colors again. Black. These are going to be our new points. We switch them around. And then take the opposite of the second one, so it's going to be negative 2. And then when we move the negative 1 over, it becomes a positive 1. Switch this one around, negative 1. Positive 4 becomes a negative 4. Switch this one around, negative 4. And the positive 2 becomes a negative 2. Those are going to be our new coordinates. So negative 2, 1. It's J prime. Negative 1, negative 4. That's V prime. And negative 4, negative 2 is K prime. So our shape would rotate around something about like that. I'm going to skip over number 6, jump to the back page, or the back of that page. Try to do a couple of these. Let's look at number 7. See if I can graph it here real quick. So that's the image, because I did the ones with the primes on them first. Now we'll do the pre-image. That's what the original shape looked like. The red one is the pre-image and the black one's the image. And they want to know, what did you do to go from each one? Well, what you can do to figure this out is just pick a point. I'm going to pick K just because it's up there all by itself. Find the coordinates of K. It's negative 1, up 3. Well, then K prime, which is right here, the coordinates negative 3, of course I put it in the wrong spot, K prime, the black K should have been right here, that should have been K prime. That one's wrong. And the coordinates there are 3, up 1. Now we gotta figure out, what did we do to go from here to there? Well, it looks like we switched them around. So we switched the X and the Y. Alright, went from XY to YX. So we we switched them. And then, when we switched them, we did the opposite. When the 3 went to here, and the -1 went to there, we took the opposite of the second one. So we took the opposite of the x, so we went y, comma, -x. And then we figure out which rule that is. And I'm pretty sure, because we did that one. So y -x, that's what we're switching to. If we go back here, we can find it. Let's look right here. Y -x, that's right there. So it could be rotation 270 degrees counterclockwise, or if we look right here, it's also there. So we could say a 90 degrees clockwise rotation. So we could say either one of those. So we could either go with 90 degrees clockwise about the origin, or 270 degrees counterclockwise about the origin. So this problem is if they give you both the pictures and they want you to decide what kind of rotation they did. Let's try another one of those. Let's try a triangle one. Let's go to number 10. Number 10. Let's see, make sure I can graph it right this time. That's U, -4, -2, -4, -2, that's X, and then -5, 3, that's S. It's our original shape. The pre-image looks something like that. And then the image looks something like this. That's U prime. That's X prime. 5, 2, 4, 5. -3. That's S prime. So it looks something like that. And again, all we got to do is pick a point. Let's pick S. The original S was 1, 2, 3, 4, 5, so -5, 3. And that went to S prime, which was 1, 2, 3, 4, 5, -3. And we gotta figure out what happened here. Well, it looks like we left the X's and the Y's in the same order, but we went from -5 to 5, so we took the opposite of the X, and then we went from 3 to -3, so we took the opposite of the Y also. So we gotta figure out which rule leaves them in the same order, but takes the opposite of both. It'd be easier if you were looking on your notes instead of me doing this. Going back through here, and we looked at a rotation 180 degrees, leaves them in the same order. Leaves them in the same order, but takes the opposite of both. And it doesn't matter whether it's 180 degrees counterclockwise or 180 degrees clockwise, they both do the same thing. So our answer for this one would be 180 degrees counterclockwise or clockwise, either one would be fine. I'll just write clockwise because it's shorter. About Alright, let's skip over to the last page. This one says, draw the rotated image. It's the first one on that page. It's got a triangle that looks like this, and it says that you want to rotate it 90 degrees clockwise. Now this one's a little different because instead of going around the origin, we're going about the point, -1, -5. And these are the harder ones. So let's see if I can find that point. -1, -5, 1, 2, 3, 4, 5. So that point right there is what we're rotating it about. And we're going 90 degrees. So what we want to do, and I'm going to draw this in a lighter color so that it doesn't affect us. Let's go with this light green right here. What we want to do is we want to take each one of these points, each one of these corners, and we're going to connect it to that. We're going to go 90 degrees clockwise, which a clockwise turn is going to turn it around that way, about this point. So we connect those two together. Notice it's a real small distance, and we want to go 90 degrees clockwise about this point. So it's going to come like a bear at a right angle. That new point's going to be somewhere right in there. And again, your drawing's probably not going to be exact. We'll call this, I don't know if they gave us any, no, they gave us no names. We'll call this A. This right here is going to be A prime. And I'll draw those in here a little better here in a minute. We'll call this B. Well, we want to go connect it to this point. And we want to go 90 degrees clockwise. So it's going to be somewhere like up in here. And what you got to do is figure out this distance from here to there. And we want it to be about the same. So let's just say if we sort of count across the blocks, 1, 2, 3, 4, it's about 5. So we want to go up this way about 5. 1, 2, 3, 4, 5, somewhere about in there maybe. That's going to be B prime. We'll call this C. Oops, that's just C, regular C. And we want to connect it to this point. And we want to go 90 degrees from 90 degrees from there, which is going to degrees from there is going to, since we're going clockwise, it's going to come down here somewhere. And it'll be about that same distance. So it's 1, 2, 3, 4, 5, about 6 blocks. And again, this is just an estimate. 1, 2, 3, 4, 5, about 6 blocks, somewhere about in there. That's going to be C prime. Just change the colors on these so we can connect them. Let's go with red. No, we already had red. Let's go with black. So this is B prime, C prime, and A prime is right here. A little tougher. Remember, your original shape was this. Does our new one look somewhat like that and rotated 90 degrees clockwise? Yeah, I'm not going to take off for the artistry. You know, my shape's probably, this one's probably a little smaller than the original one, it looks like, but it's real similar. And if we turned it the correct way, we turned it around this way, and we turned it about 1/4 of a turn. So that's what you need to be able to do, just sort of estimate that. You gotta be able to estimate your angle of your turn. So you gotta be able to estimate the angle of the turn, and that's what I was doing with all these little green lines. And you also got to be able to estimate the distance that each point is from the point that you're rotating it about. Let's try one more of those. I'll draw another one on here, see if we can, let's see here. Let's do the fourth one on that page. Got the real little skinny triangle on it. See how well we can do that. Let's see, it goes 3, -2, 3, -2. That's somewhere about in there. We'll call that point A. 4, 0. It's right there. We'll call that point B. And 3, 1, 2, 3, 4, 5, 6. 2, 4, 6. We'll call that point C. So our original shape looks something like that. I could hit the points. And we want to rotate this one 180 degrees about the point 2, 1. So about the point 2, 1. 2, 1 is right there. We'll call that point P. We're rotating it about that point. Let's get let's get this light green one again. So we're going from, we went from here to there, and we want to go 180 degrees. So it's actually going to come off of that 180 degrees. It'll come straight up in here somewhere for point A. We want it to be that same distance, and it looks like it goes across about 3 blocks. 1, 2, 3, so somewhere right about in there. That'll be A prime. B, 180 degrees isn't too bad because you know your angle is going to be a straight angle. So from B, I'm going to go straight over from P, over this way. It goes across about 2 blocks, so maybe somewhere right there is going to be B prime. Then C, 180 degrees. It's going to come straight down here somewhere. And we're going to go 1, 2, 3, 4, about 5 blocks. Might learn this straight. Looks like it's going to come over this way a little bit. 1, 2, 3, 4, about 5 blocks, somewhere right about there. That's going to be C prime. Let's change the colors here. Let's go to red. So we got C prime, it's right there. B prime, it's right here. A prime, it's right there. We connect them. Should get about the same shape. Well, it doesn't look too good. About the same shape, just rotate it around 180 degrees. Looks like I got my B. My B should probably be out here a little farther. And put it out quite far enough. So rotating around that 180 degrees, this shape right here. Looks about the same. Colored in, so you can't see my mess up. So it's a little tougher if you're going around some other crazy point, and if you're using some angle like 60 degrees or 50 degrees, that makes it even a little harder still, because you got to do a little estimation with the angles. All right, that's the assignment.